What is a capillary action? And why can water seemingly climb against gravity? Imagine dropping a paper towel into a spilled glass of water. You watch it slowly pull the liquid upward, against all odds. This simple scene hides a powerful mystery that drives life in plants and even ink in your pen. Let's rewind for a second. You're watering a houseplant, and you notice something strange. The soil is dry, but the leaves are hydrated and glowing. You think, how did water from the pot make it all the way up the stem? You've just witnessed a perfect example of capillary action in action. So how does it work? To explain the capillary action, you first need to understand how water behaves. Water molecules are sticky, not like glue, but in a molecular sense. They attract each other through cohesion, and they attract other materials through adhesion. When both forces combine inside a thin tube like the stem of a plant, magic happens. Water begins to climb upward, pulled by adhesion to the walls and cohesion between molecules. This rising motion is what scientists define as capillary action. And it's not just in plants. Ever seen ink slowly travel up blotting paper? Or wine creeping up the sides of a glass? That's capillary action doing its quiet work behind the scenes. The narrower the tube, the stronger the effect. That's why water can rise higher in very thin stems or fibers. Capillary action is crucial in nature, but it also powers human inventions. From fountain pens to thin layer chromatography, it's everywhere. In fact, it's the reason you can dip a sugar cube in coffee and watch it soak up the liquid without a drop being poured. Still wondering how tall trees get water all the way to their top leaves? Capillary action, combined with transpiration, pulls moisture up like a natural pump system. Without it, plants would dry out. And so would we. Engineers even use this principle in microfluidic devices for medicine and tech. Tiny channels mimic plant stems to move liquids with precision. In science labs, capillary tubes help determine surface tension and viscosity. Yes, even those glass tubes we barely notice are built on this force. To define capillary action simply, it's the upward movement of liquid through a narrow space, defying gravity, thanks to adhesion and cohesion. But beyond the definition, it's a natural phenomenon that quietly supports entire ecosystems and human innovation. So the next time you see water crawling up a tissue or a flower standing tall, remember, what is a capillary action? It's not just science. It's the invisible lifeline beneath leaves, ink, and even your morning coffee.